Hello, welcome to our AP Physics 2 pre-flight on fluid dynamics. My name is Leonard Krueger.
And I'm Minarro.
This is the first unit of AP2, so you should know all the material covered in AP Physics 1. As you can see, Goku is not at the bottom left corner.
Density. Density is mass over volume, as you can see on the equation at the top right of the page. The standard unit of density is kilograms per meter cubed. Density is essential for this unit as it plays a role in determining the buoyant force and pressure. The average density for water is 1,000 kilograms per meter cubed, and the more precise measurement for water is 997 kilograms per meter cubed. As you can see at the bottom right corner of the screen, there are two cubes labeled by density. The left cube has less balls, which means it is less dense, while the cube on the right has more balls, which makes it more dense.
For pressure, pressure equals the force over area. Units are either N over meters squared or pascals, modeled by P with a subscript of A, which is area. Hydrostatic pressure is the pressure caused by water when it is stationary, modeled by the equation P equals density of liquid times 9.81, which is the acceleration constant, and the depth. As you can see on the diagram at the bottom, the user is holding the hose. He's putting pressure on it so that the stream of water is more direct, and on the left, but on the right, he's putting no pressure on it, meaning that the water is falling down and not coming out as a direct stream. Pressure is modeled by force of area, as I already stated.
Pressure continued. Atmospheric pressure. The atmosphere is a fluid tool. Fluids are not only things such as water or blood, but also gases. Total pressure. Gauge pressure is pressure relative to the amount of pressure. It is the pressure difference between two objects relative to each other. Total pressure is the volume of all pressures added together.
So for buoyancy, buoyancy is a force, which means it is a vector. If something floats, the weight of the displaced fluid is equal to the weight of the object. However, if something sinks, the volume of the displaced fluid is equal to the volume of the object. The buoyant force is modeled by rho times volume times gravity, so 9.81. As you can see in the diagram on the right, the boat on the left is floating because the displaced fluid is equal to the weight. However, the object on the right is sinking because the displaced fluid is equal to the volume of the object.
How boats float. Boats are held upward due to the displaced water constantly pushing back on the object, trying to fill in the gap that it is creating. As stated before, if something floats, the weight of the displaced fluid is equal to the weight of the object, and shape is undoubtedly the most important factor as it can break it or make it in terms of displacing fluids. As you can see on the picture on the bottom right, the buoyant force is acting upon the hull of the boat, and so it's floating.
This is our bibliography, and as you can see, Goku is now in his final form, Ultra Instinct.